Hi everyone, so today we're going to be talking about another quadrilateral in the quadrilateral family. This shape is called a trapezoid. And we've talked a little bit about trapezoids this year, but a trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. Now, that exactly one's important because if I had both pairs of opposite sides parallel, then I'd be a parallelogram. And a trapezoid is not in the parallelogram family. It is not a special parallelogram. It is a quadrilateral with only one pair of opposite sides parallel. Now, those opposite sides, they're called the bases, okay? Those parallel sides are called the bases. Usually we call the top one, the smallest one base 1 and the largest one base 2. It doesn't really matter what you call them, though, but they're both bases, which can be hard sometimes for us to think about. When we think about a base, we always think about the bottom side. So a trapezoid has two bases, okay? And then the opposite sides, the ones that are not parallel, we call those the legs, okay? We've spent a lot of time talking about trapezoids, but what I want you to make sure you understand is that a trapezoid doesn't have to look like the one on the right. It could look like this, where it's kind of sideways. It could look like this, where those are the parallel sides, or it also could look like this. Now, the nice thing about trapezoids is that they're made up of other figures. If you drop altitudes, remember heights, perpendicular segments in each of them, then you'll see that it's got rectangles and triangles. So it's always going to have at least one rectangle and at least one triangle. But it also could be a situation like this one where it has two triangles, which is nice if I ever wanted to calculate the area and I just couldn't remember the trapezoid formula. But that's one thing. What else do you already know? We've spent some time this year talking about a trapezoid and its area formula. So as a reminder, to find the area of a trapezoid, we do the bases, we add the bases, so we take the sum of the bases and we divide by 2. So the average of the bases, and we multiply it times the height. Now, that may look a little familiar to you because it looks similar to the triangle formula. And we're going to derive this formula actually when we talk more about area. All right, so let's talk about this trapezoid. A trapezoid actually has this really cool part to it called a median. Now, we've talked about a median before, but we talked about it with a triangle. So just as a reminder, a median of a triangle is a segment that comes from a vertex, any vertex, to the opposite side and hits it at the midpoint. And so a triangle has 3 medians, like this. We just talked about that median of a triangle. Well, the median of a trapezoid, sometimes referred to as the midsegment. I'm going to use both because books use both and tests use both. Median or mid-segment of a triangle. It does, in fact, hit each side at its midpoint. Okay? So these points right here are at the midpoint. And it's also parallel to the bases. Okay? So it's parallel to the bases. That's really cool, though, because now if I've got parallel lines, look, I've got corresponding angles here and here. And I actually have corresponding angles here. Let me put 3 there. And here, 2, 3, 4. 1, 2, 3, 4. Now you might notice I didn't mark them all congruent because we don't know that those are all congruent. We don't know anything about the angles of the trapezoid yet. Now, the most important part about this median is that it's pretty easy to find its length, okay? So the length of a median, so a median is equal to the average of the bases. The average of the bases. So I'm going to call this base A and this base B, and I'm going to call this M. So if we want to find M, we take A plus B and divide it by 2. Now remember, when we find average, we're taking the sum of the number of items I have and dividing by the total number of items. Since we have 2 bases, we add the 2 bases and we divide by 2. And that's how we find the length of the median. All right, let's try that. So here we go. We have a trapezoid. They tell us EF is a median or a midsegment. So I immediately mark that and I immediately mark my parallel lines. If that's my given information, mark your diagram with the given. All right, then it says that AB is 25, DC is 13, and wants us to find EF. All right, well, I'm going to call it EF. I'm going to call it M for median. All right, so I'm going to write a formula. So M is equal to 13 plus 25 over 2. All right, so now I'm going to follow order of operations, and remember that fraction bar is a grouping symbol, GEMDAS. So I'm going to do 13 plus 25, which gives me 38 divided by 2, and that gives me 19. Okay? All right, so let's think a little bit more. Here's a trapezoid and a median are shown. What do we know about the median of the trapezoid? Well, we know that number one, it's parallel to the bases. We can actually see that it's the midpoint because these are equal. And we know that the median is equal to the average of the bases. All right, so I'm going to write an equation because these have variables in it and see what I can do. So I'm going to say my median, which is 10, is equal to the average of the bases. So we add the two bases. So 2x minus 4 plus x minus 3 divided by 2. All right, so now that looks linear. Why? Because the highest exponent's a 2, so I'm going to simplify. So 10 equals, well, 2x plus x gives me 3x. Negative 4 and negative 3 gives me negative 7. Now that's divided by 2. Now, a really nice thing to do right here would be to clear fractions. So remember, we clear fractions by multiplying both sides by the lowest common denominator, in this case 2. So I'm going to multiply both sides by 2. The 2's over here are going to cancel, and then 2 times 10 gives me 20. So 20 equals 3x minus 7. All right, now again, a linear equation. Why? Because the highest exponent's a 2, so I'm going to add 7. I get 27 equals 3x, and therefore x equals 9. All right, so that's how we can use this concept of a median or midsegment of a triangle to find missing lengths of a trapezoid. Of a trapezoid. And what's really cool now, guys, you don't even know this, but you could even do calculus. This is actually a calculus question. This is a polynomial curve, and sometimes what they'll do is they'll ask you to find the area under the curve. Well, if you notice, you could actually take all these different little trapezoids and calculate their areas and then add them all up. So even though we're only in geometry, we're learning skills that we're going to use as we progress in our math career. And hopefully you guys will get a chance to see that before you leave St. Luke's. Have a great day. Bye.